guys, so in this video I'm going to go over how to compute the unit normal vector. So notice right here I have two formulas. I have the unit tangent vector formula. If you don't know how to compute a unit tangent vector, watch that video first because you need to know how to do a unit tangent in order to do a unit normal. So capital T of lowercase t of r prime of t divided by the magnitude of r prime of t is unit tangent vector. Unit normal vector, however, goes a step further. So the derivative of unit tangent vector divided by its magnitude. So without further ado, we're going to compute the unit normal vector of this problem. So right here we're given the position vector r of t is equal to 5 cosine t comma 5 sine of t comma t. So we're given three elements in this. So what we do for step 1 is we're going to find the unit tangent vector. Again, if you don't know how to find unit tangent, go watch that video first, then come watch this video. So anyway, so the unit tangent vector, we have r prime of t, which is equal to positive 5 cosine of t, positive 5 sine of t, and t. R prime of t, the derivative of that, when we differentiate this, the derivative of 5 cosine t is negative 5 sine of t. The derivative of 5 sine of t is 5 cosine t, and the derivative of t with respect to t is just 1. So that's our r prime of t. So now what we need to do is find the magnitude, the r prime of t magnitude. So what we do, square root, add them together. So negative 5 comma sine of t squared plus 5 cosine of t squared plus 1 squared inside a square root. So that's our unit normal vector. So what we're going to do now is, the first thing we're going to do is we're going to distribute the square. So we know 25 sine squared t plus 25 cosine squared t plus 1 inside a square root. And all I did was distribute the square. Now in the next step, what I'm going to do is, notice how we have 25 on two terms. So we can factor out the 25 of sine squared plus 25 of cosine squared. And that's what those orange brackets represent, plus 1. The 1 is not taken in consideration when factoring. So that's the magnitude. So now we know the Pythagorean identity sine squared plus cosine squared is equal to 1. So we're going to substitute sine squared plus cosine squared with the 1. And notice how this problem just became a whole lot easier because we know 25 plus 1 is equal to the square root of 26 when it's inside a square root. So that's our magnitude. So now we have the sufficient amount of elements to compute the unit tangent vector. So the unit tangent vector would be r prime divided by the magnitude of r prime of t is equal to negative 5 sine t comma divided by the square root of 26 comma 5 cosine of t divided by the square root of 26 comma 1 divided by the square root of 26. And that's the unit tangent vector. So now for step 2, now that we have our unit tangent vector, what we're going to do for step 2 is we're going to find the derivative of the unit tangent vector. So our unit tangent vector was negative 5 sine t comma positive 5 cosine t comma 1, all divided by the square root of 26. So that was our unit tangent. So what we're going to do now is we're going to take the derivative again. And it can look a little daunting, but just know that negative 5 divided by the square root of 26 all itself is one constant. So the derivative would be negative 5 of cosine t, negative 5 divided by the square root of 6 cosine t, and then the derivative of cosine is negative sine, and then multiplied by the constant of negative 5 times 26, and the derivative of 1 over 26 at the square root of 26 is just 0. And I'm going to write this division line because now we're going to move on to step 3. Now that we have the unit tangent vector derivative, what we're going to do in step 3 is we're going to find its magnitude. So we're going to compute magnitude one more time. So magnitude would be, we get the terms, so we get the terms of the unit tangent vector, -5 divided by the square root of 26 cosine t, and then we square it, and then we do the same for each other term. And what we're going to do is we're just going to distribute the square. So when we square 25, -5 times -5 is positive 25 over 26 cosine squared t plus 25 over 26 sine squared t plus 0. So all I did was just distribute the square to each term. So square in the radical will cancel out, so that's why we get 26. -5 squared is positive 25. So now what I'm going to do over here is I'm going to factor out the 25 over 26 for sine squared plus cosine squared. Because they both have a 25 over 26, so I'm going to factor that out and eliminate the 0. In doing so, we know the Pythagorean identity of cosine squared plus sine squared is equal to 1. So essentially we can just substitute it with 1. So 25 over 26 times 1. The orange brackets are for, so that way you know that cosine squared plus sine squared is being substituted with the 1 because it's equal to 1 according to the Pythagorean identities. Sine squared plus cosine squared is 1. So now we're just going to take the square root of this. We're going to simplify this a step further. We know the square root of 25 over 26 is 5 divided by the square root of 26. So that's that's the magnitude of the unit tangent vector. So now we can compute the unit normal vector. So for step 4, what we're going to do is we're simply just going to plug in into the unit normal formula. Again, so the unit normal formula is the unit tangent vector prime divided by its derivative, or the unit tangent vector derivative divided by its magnitude. So again, what was capital T prime? We computed it to be -5 over the square root of 26 cosine t divided by -5 square root of 26 sine of t, comma 0. So that was our unit tangent vector derivative. And the magnitude of this was positive 5 over the square root of 26. So now what we do is we're going to compute this by plugging into the formula. So capital T prime would be -5 over the square root of 26 cosine t divided by the magnitude, -5 over the square root of sine squared t divided by the magnitude, 0 divided by the square root of 26. And also I did forget to put the square root, but there's a square root right there where the 26 goes. So anyways, what we're going to do now is we're simply just going to cancel out like terms. So those cancel out, and then the -5 with the square root of 26 also cancels out in the middle term, and then the last term goes to 0 because 0 over anything is 0. So our normal tangent vector, after we do all the simplification, the normal tangent vector comes out to be negative cosine of t, comma, negative sine of t, comma, 0. And that's how we compute the unit tangent vector. So step 1, unit tangent vector. Step 2, the unit tangent vector derivative. Step 3, the unit tangent vector magnitude of the derivative. And step 4, unit normal vector, and by plugging into the formula. So in this example, we're going to compute the unit normal vector of the position vector of 12 cosine t, 12 sine t, 5t. So without further ado, the first step we do, as in the previous problem, we find the unit tangent vector. And we use the formula r prime of t divided by the magnitude of r prime of t. So Our R of t is 12 cosine of t, comma 12 sine of t, comma 5t. So when we take the derivative of this, we compute it, we get negative 12 sine of t, 12 cosine of t, 5. That's r prime of t. And then for step 2, or the next step, better said, would be to compute the magnitude of this. So negative 12 sine of t squared plus 12 cosine of t squared plus 5 squared. That's the magnitude. So what we're going to do now is we're just going to distribute the square. So 12 squared is 144. Sine t squared is sine t squared plus 144 cosine of t squared plus 5 squared is 25. So now notice how we have a common factor in the 144 sine squared plus 144 cosine squared. So what we can do over here is we can actually just pull out the common factor between those. So 144 times sine squared plus cosine squared plus 25. And the 25 is at all not involved in the factoring because we're only factoring two terms. That's why I have parentheses around the sine squared plus cosine squared. And if we know the Pythagorean identity, we know sine squared plus cosine squared is equal to 1. What's in the orange parentheses? So we can substitute that with 1. So 144 times 1. And notice how they're both in orange parentheses? That's so you can follow along. So 144 times 1 plus 25. So that's our r prime of t. And when we simplify this, we know that it's 144 plus 25 is 169. And 169 is a perfect square for 13 when we take the square root. So that's our r prime t. So now to get the unit tangent vector, we need r prime divided by the magnitude r prime of t. And we use this formula right here. And the unit tangent vector thus is negative 12 sine of t over 13, comma 12 cosine of t over 13, comma 5 over 13. And that's the unit tangent vector. So now we can move on to step 2. So now that we have our unit tangent vector, for step 2 we're going to find its derivative, capital T prime. So the unit tangent vector we computed was negative 12 over 13 sine t, positive 12 over 13 cosine of t, and then 5 over 13. So when we take the derivative of this, we get the derivative of negative sign is negative cosine times the constant, which is 12 over 13 in this case. The derivative of cosine is negative sign. And the derivative of 5 over 13, or any constant, is 0. So that's our unit tangent vector derivative. To get the unit normal vector, we need to compute the magnitude of that. So when we compute the magnitude of this, we get each term, square them, add them, square root them. So we compute the magnitude, we get negative 12 over 13 cosine of t squared plus negative 12 over 13 sine of t squared plus 0 squared. So now what we're going to do is we're going to distribute the square to each term. So t prime square magnitude would be negative, or 12 squared is 144, 13 squared is 169, cosine squared is cosine squared plus 144 over 69 sine squared plus 0, 0 squared is 0. So now what we're going to do is we're going to continue to further factor this, and we know that we can factor out the 144 over 169 because it's common for both sine squared and cosine squared. And we know the 0, we can just eliminate it. And we know the Pythagorean identity sine squared plus cosine squared is equal to 1. So what we can apply now is we can apply a substitution. So 144 over 169 is a common factor, and then sine squared plus cosine squared is equal to 1. So we can substitute a 1 in there. And now this problem's a whole lot easier to compute. So we know that this is going to be equal to 12 over 13 because we know 144 square rooted is 12, 169 square rooted is 13. So that's our t prime of t. And now in step 4, we're going to plug this into unit normal formula. So the unit normal formula we know is t prime divided by the magnitude of t prime. And now we have it. We have t prime, negative 12 over 13 cosine t, negative 12 over 13 sine t, comma 0. And we have the magnitude, which is 12 over 13. So the unit normal vector is negative 12 over 13 cosine t divided by 12 over 13. Negative 12 over 13 sine of t divided by 12 over 13. And then 0 divided by 12 over 13. And now we're going to do a lot of simplifying. Notice how we have common factors, common things we can cancel out. And we're going to cancel out the 12 over 13 for the first term. In the second term, we're also going to cancel out the 12 over 13. That's in the numerator and the denominator. And in the last term, we know that whole term having a 0 in the numerator goes to 0. So furthermore, when we simplify this, we get the unit normal. When we plug this into unit normal formula, we cancel out all the like terms. We're left with negative cosine of t, comma sine of t, comma 0. And that's the unit normal vector. So step 1, unit tangent vector. Step 2, its derivative. Step 3, the magnitude of that. Step 4, plug it into unit normal formula. It's as easy as that. Plug, chug, derive, solve. Just make sure you don't mess up with the arithmetic. These problems were very simple, but the problems do get a lot harder. Thank you for watching. I hope that was helpful.